Okay, students, so you have understood what is set, right? Set is a collection of well-defined and distinct. Now, distinct, I told you I will explain while doing exercise only, right? So, see what is the meaning of distinct. First thing, let me take a example. Suppose I have 5 eggs in reality, okay? 5 eggs if I have in reality. Now, all these eggs look identical, right? Yes or no? You won't be able to figure out the number. If I change the position also, you won't be able to figure out. That is called identical, right? Now see, in reality you will know that it is 5x. Now when you have to write down in mathematical form, how you will write down? Set of x, suppose I will write denoted by E. Now when you write under set, obviously we know that how many elements are there? 5 elements. Now how you will write the elements? Eggs, 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 eggs. You cannot write like this, right? Because the other person must be able to figure out. Okay, now see, in maths we cannot write eggs, eggs, eggs. You have to tell exactly which eggs you have collected here. The first eggs will be this one, suppose. Second egg this, third egg this one, fourth egg this one, fifth egg this one. Now the other person must be able to figure out. If it does not have also this one, these eggs are suppose placed in different place. Okay, and he must be able to figure out with this collection only that this eggs, the person is referring to this egg is referring to this. He must be able to figure out. Now see, when you place this one in other place, it does not mean that you will place exactly here in this position. You might change it. Now the moment you will change it, you won't be able to figure out here, right, in mathematical form. So that's why whenever you have identical object, remember we used to named it. For example, I will name this egg E1, E2, E3, E4, E5. I will name it like this. Okay. Now when you write down in the set this collection E2, E3, E4, E5. If you change the position also does not matter here. Now if you write down the set in this way and you have given the name suppose, then any person who will see this collection, he can easily figure out that this egg is this one, this one, this one, this one and this one, right? So that's why you can see whenever you have identical element, we used to name it in a different form, right? That's why in case of C, in case of number also, suppose you will give number to this one, 1, suppose 2, this one 3, you have given this one also name 3 suppose. This is also 4. Now when you will write down in the collection here 1, 2, 3, 3, 4 like this. Now 1, 2, 3, okay fine, you can easily 1 to 4 you can easily figure out. This egg is this one you are referring, this egg is this one you are referring, this egg you are referring to this one. Now the problem is with this 3. This 3 you are referring to which egg? This egg or this egg? We won't be able to figure out like this. So that's why in case of set, when we write elements, to not make confuse, what we used to do is we never repeat any elements. If you have identical elements also, we used to give them different name and then we put it as, suppose I will name this one as 4, this one as 5, this one 3, this one 4, this one 5. So if you write mathematically same element again, same repetition of number or alphabet again, if you write, then it will make you confused with the real form. Okay, but whatever object you have in the real form, there it will make it confused. So to remove this confusion, what we have done is in set we never repeat any letter or number in the set or anything in the set. We don't repeat things, okay, because if you repeat, again I repeat, you will get confused in reality, right? So even if you have identical object, we know that it is distinct, different object we know, but if it is identical in set, we name it in a different form and we write down so that there will be no confusion. You will know that exactly this element, this 3 element is this one, this element is this one. So eggs, easily you can figure out which eggs you are referring here. And how many eggs are there? 5 eggs exactly. So that's why in set we never repeat any element. Even if it is identical, we used to give different name. Okay, so you need to remember this. Never repeat any element. Okay, we don't repeat. That's why we used to say collection of distinct object. Now see why collection of distinct object. For example, if you write suppose 3 3, then also you have this 3 you will refer for different element, this 3 you will refer for different element, right? But due to same number there will be a confusion. But we know that these are distinct object, different object. That's why we used to say collection of distinct object. I hope you have understood. Each and every element here are different, even this and this also different. That's why, not to make confused, we used to write different number. We never write same number for two identical element. Okay, so that's why whenever you write set, we will understand that this element is different, this element is different, this element is different, this element is different. No element will be same here. There will be no repetition. Okay, so that's why it is called collection of distinct objects. So it is not written in your textbook. Okay, the definition is only given well defined, but actually it should be the word distinct also, which should be mentioned in the definition. Okay, so always set is a collection of well defined. This must be well defined, all object must be well defined, and all object must be different. That's what we understand. Okay, even if you write same number also, it must be different. But since we will get confused which element you are referring, that's why we use different number. We never repeat here the element also. Okay, so I hope you have understood what is distinct element. Distinct means very simple, different element, you can say. Okay, even if look identical, you must understand that when we write in a set like this elements, we understand that each element after comma, each elements are different. Okay, and one more thing, when you collect, for example, if I give you randomly 1 2 3 4 5 these numbers, you write down in a set. So when you write down in a set, it does not mean that exactly you have to write 1 first, 2 first, 3 first, 4. You can collect in a different, because when you make collection, you don't see the position and all, right? You can give directly, you can pack up 5, you can put in the first position, 2 3 here, 4 here, 1. So in case of set, remember, order also does not matter. Okay, order does not matter whether you write like this or write like this, both are same. Okay, so in set, order does not matter, whether you write in this position or this position does not matter. Okay, if all elements are same, we say sets are same only. So this also we will discuss. This is called equal set. Okay, equal set we will discuss after this. So with this, your first exercise is over, right? For next exercise, we have some different types of sets which we need to know. Okay, so okay, one more thing. In your first exercise also, this question you might have seen, right? Number 6. Can you see? They have said the set of all letters in the word better. So when you collect this better word, they have asked you to collect the letters from this word better, right? So when you write in the set, what will be the letters here? B, then E, then T. Now this T you cannot repeat. Okay, E, then R. As I said, in set we don't repeat any element. Okay, so T you cannot repeat again. Okay, so this will be the collection, and E also, sorry. So I may make mistake like this. Okay, you have seen, right? I have written E again. So you cannot repeat the element. That's what I mean to say. Okay, you don't repeat element in the set. So this will be the collection here. Okay, same way in other set also, if you have any same type of element, don't repeat it, just write once that. Okay, so with that, let's start different types of sets. Now see here, sets you have understood, it is nothing but collection of well defined and distinct object, right? Now see different types of collection we have. Empty set, sometimes empty set also called null set or void set. Try to understand whenever they use this word, try to understand they're talking about empty set only. Okay, now what is empty? By the word itself you can understand. Empty set, what do you think it will be? In a set there will be nothing, empty. So means when there is no element in the set, that kind of set is said to be empty set. A set with no element, with no elements, is called empty set, or as I don't need to use, right? A set with no element is called empty set and is denoted by this symbol. This is read as phi. Okay, phi, just like this. Okay, this symbol is denoted for empty set. This is a special kind of symbol. Again I repeat, whenever there is a special kind of symbol, better don't use those symbol for defining other set. Okay, so phi don't use for other set. Always this symbol is used for only empty set. Okay, so example it is given here. See, a set of, can you give or can you think about empty set example? Obviously you can easily think, right? You think about that set where there will be no element. So see here, I have also written one example. A set of natural number less than 1. So can you tell me set of natural number less than 1? Obviously no, right? There is no element, such element. So phi is equal to, it is also written like this. You can see the set. This is notation. Okay, and this is how we write set. Curly bracket, inside we used to write element, right? Now there is no element, what you will write? Leave it empty. So this is your empty set, and this is the notation. Okay, sometimes student, what they used to do is, inside curly bracket they used to put phi. Remember, this is not a correct notation. Phi is the notation of set. As I said, right, for a set of natural number, how we used to notate? Like this, capital N. For whole number, capital W. Okay, now you might be thinking, right, why I'm putting like this in place of N? Because this is not a normal N I'm writing. If you write simple N like this, we don't understand that this is a natural number or your different kind of set. So to differentiate it with the normal kind of set, different normal set, to differentiate it, we used to put this kind of N, or you can put bold N like this, dark one, like this also you can write. Okay, so these are special kind of sets whose symbols are universally used. Okay, everywhere you will see natural set of natural number, they will use N. Set of whole number, they will use W always. Okay, so that's why these are given special notation like this. So better I will suggest, for special set only use, for set of natural number only you use this. For normal set, different kind of sets, you better use different symbol. Okay, so next, finite set. What is finite set? By the word itself, finite, you have understood, I guess. It means there must be some end. Okay, when we count something and we end up, that is called finite, right? Finite means some end is there. Okay, so finite set means what? A set with finite number of elements. Means finite means you can see end, you can see there will be end of some set. For example, A 1 2 3, this is finite set, only 3 elements, right? You can count and can end up 3 element only. But if I say set of natural number, will it be finite? Obviously no, because you can never end counting this one, never end. So when you end up counting it, then that kind of set, it is called finite set. Very simple definition, right? By the word itself you can understand. Next is infinite set. Obviously the one which I have said, set of natural number example you can see, which never ends. I have also written in the bracket. Okay, so you can write down there. Example, set of natural number that never ends is called infinite set. Okay, next is equal set. By the word itself you can understand equal set, and I say, right, I will discuss this one. Equal set means what? Two set equal. Now when it is said to be equal, two sets, say A and B, suppose you have two sets, say A and B, are said to be equal set if both set, means both A and B set, have same elements. I hope you have understood. Suppose for example A is having elements 1 2 3 and B is also having 1 2 3. Order does not matter, so if you write in different position also does not matter. So you can see in this case, how many elements are there? 3. Here also 3. And what are the elements? Here also 1 2 3, here also 1 2 3. So these two sets are said to be equal, and you can write the set like this: A is equal to B. Okay, so this is called equal set. So with this definition only you can solve your second exercise. Okay, so but I will discuss some more definition for your next exercise also, or I think the video will be too lengthy, right, if I discuss all the definition again. Let's do some question based on that topic only. Okay, as you know, uploading it will be very difficult if the video is too lengthy. Okay, so I'm not starting this topic. Let's do some questions and then you start yourself. Okay, so in this case you see exercise 1.2. Which of the following are examples of null sets? So they are asking you which one out of this sets which is given here is your null set. Where is my pen? Here it is. Okay, so which of the following are example of null set? So first one, null set means you have understood, right? There should not be any element inside the set. Okay, so if you have such kind of set, that is called null set. So you can see first one, set of odd natural. You just have to say which one is null set. Okay, set of odd natural numbers divisible by 2. Now do you have any set of odd natural number which is divisible by 2? Obviously no, odd numbers can never be divided by 2, right? So you will never get such kind of element. So this is your null set. I hope you have understood. Your odd numbers are what? 1, 3, 5. These are odd natural numbers, right? 7. Now can you divide this by 2? Divide this by 2 means what? Your quotient should not be in decimal. It should be whole number always. Okay, that is called exactly divisible. You know factors and all, right? So this will never be divided by 2. That's why this set which they have said is null set, as you cannot get any element there. Okay. Next, number 2. Set of even prime number. So do you have even prime number? Yes. What is your first prime number? Prime number means what? That number is called prime number which have two factors. Two factors always. So 1, is it a prime number? No. Why? Because it has only one factor. What is the factor? Only 1. No, a factor means what? The number which divides exactly. That is called factor, right? So this is divisible by what number? Only 1. You need two factor always, exactly two factor. Those numbers which have exactly two factor is called prime number. Now what about 2? 2 can be divided by 1 as well as 2. So two factors are there, right? So 2 is your first prime number. Okay, next 3, will it be prime number? 1, 3. In this way you can always find out which one is prime number, those who don't know. Okay, so you can see this is your even prime number, right? Rest, whatever prime number you find out, it will be always odd. You will never find even prime number other than 2. Okay, now they have said in your question set of even prime number. Set of even prime number. So even prime number you have or not? Yes, you have 2. So you can see in this set element is there. So this is not a null set. Okay, so question number 2 is not. Number 1 null set, number 2 not a null set. Okay, now next number 3, set of element. Where what is the element here? X. Now what is x? X is a natural number. Now if I stop there, all 1 2 3 4 5 6 all will be your element, right? But see, they have given restriction. What is x? X is a natural number. Now they have said x less than 5 and x greater than 7. Okay, this question is actually a little bit confusing. The reason is they have said, see here carefully, they have said it is a set of element where the element is x, right? Now what is x? X is a natural number. If I stop there, element will be 1 2 3 4 5 6, it will go on. Now what restriction they have given? X is less than 5 and x is greater than 7. Now x is what? It's a variable, right? Now when they stop here, actually the element will be there. X is less than 5. What are the elements? 1 2 3 4, and they have said x greater than 7, so element will be 8 9 10. But you will see in the back side it is actually written it is a null set. Now see why they have written. The reason is they are actually, what they want to say here is x is a natural number, and what is x? X less than 5 and greater than 7 simultaneously, they want to say. Means at the same time, the element which you will have here, it must be less than 5 also and greater than 7 also. Now 1, obviously it is less than 5, but it is not greater than 7, then you cannot include this element. That's what actually they wanted to say here. Okay, it should be simultaneously. They didn't mention this one here, but it should be there. That's why they have said this is null set. Okay, now if they stop here, actually it should not be null set here. Okay, in the back side you will see it is written null set. Okay, I hope you have understood. It should be simultaneously. They want to say here is what? X less than 5 also, x greater than 7 also. That kind of natural number you have to write. I hope you have understood. Can you have such kind of numbers which will be less than 5 also, greater than 7 also? What natural number it is? Not possible, right? You cannot get that kind of element. So they have missed out the word simultaneously here. Means they want to say at the same time this condition must satisfy, not separately. If they stop here, we understand that x is a natural number less than 5. Less than 5, what are the numbers? 1, 2, 3, 4. And x greater than 7, what are the numbers? 8, 9, 10. Like this it will come out. So element will be there. Actually this won't be a null set. But what they actually wanted to say was simultaneously. Means at the same time, not separately. X less than 5, not like that first. Then x greater than 7, not separately like this. They wanted to say those element which is less than 5 as well as greater than 7 also. So obviously 1 is less than 5, it's correct, but it is not greater than 7, then you cannot take this. 2 is less than 5 but not greater than 7, cannot take. Less than 5, not greater than 7. At the same time, those both must satisfy. That's what they wanted to say. Okay, I hope it's clear. So this will be null set according to that definition I said, if it is simultaneously. Okay, that's what they wanted to say in the question. So try to understand the question carefully, okay? And if I make any mistake while writing, then try to correct me. Like last time, one of the student, she said that I have written there. I said that preceding K, all the consonant letter you have to write, right? So I have written E also, it seems, in the set. So you just correct those things, okay? So while saying whatever I will say, you just listen carefully, and while writing I may make mistake, because most of the time I have to see the camera also whether it is focusing or not, because most of the time my camera go out of focus, so the video get blurred. That's why I have to keep on watching my phone also, okay, whether it is clear or not. So if I make mistake, do correct me, okay? And as you know, online class, it's very difficult to take because we are not habituated with that, right? So it takes little time to adjust. Okay, so your next question is y. Set is y, right? Element is y. Okay, now what is y here? Y is a point common to any two parallel lines. Y is a point common to any two parallel lines. So y is what? Okay, so see carefully. It is a set of collection where the elements are y. Now what is y? Y is a point, means the element which you will write here will be a point. You know, right, what are points? In graph we used to plot points. Remember, coordinate of it, always x coordinate and y coordinate used to have. So those kind of element will be there. Now the question is, what points? Y is a point common to any two parallel line. Now see here, if you have a parallel line, okay, now in this two parallel line, can you have common point? Common point means same point which must lie here also, here also. Can you have? Obviously no. All the points you can see, it will be separated. You cannot have common point like now. Obviously it will not have any common point. Now some student might be thinking like this. You have different kind of parallel lines, right? Now parallel lines is like this also. You have one line here. Over this only another line you have. Right? Now in that case, all point will be common, right? What will be the set here? Now see here carefully. In your question they have said y is a point common to any two parallel lines, they have said. So when you will write down points here, I will try to find out this point must be common to any two parallel line I will take. So if I take this two parallel line, then also it must be common, this point, because they have said any two common parallel line, any two. Okay, so they didn't mention you that it should be coincident one. Remember in class 10 you have done, right? This is called coincident condition, right? This is also parallel line, the line which is lying over one another. Okay, so this is also parallel line where the angle is 0. You know that, right? Okay, so obviously in case of parallel line, always the angle will be obviously 0, right? This also will be parallel. Okay, anyway, here also angle will be 0. Between these two line also parallel, angle will be 0. So in this case, infinite number of points will be there. So according to that, infinite points must be there, right? But they have said any two parallel. Means when you write down element here, I will check these elements are lying in any two parallel line or not. I will take any two parallel line and I will see whether this lies on here or not. So if I take in that way, in this way I will take parallel line, you will never find points here. Okay, you will never find. So means what? I am not able to find out these points, right? Means this is not a correct answer. You cannot write these conditions here. When you write down here the elements, it must be general one. Means for any two parallel line it must satisfy. So obviously this is also null set. You cannot have any element here. I hope it is clear. So set, always remember you have to be very specific when you write down the set. Definition, see carefully and see what they have said in the question and try to compare and see whether you are getting that only or not. Okay, so you need to compare properly. So in this case also null set, you won't get any element here. Okay, next is which of the following sets are finite or infinite. So that will be very simple, I guess, for you, right? The first question is the set of month of a year. So set of month. So what are the months? January, February, like this. You will end up, right? December. Yes, there is an end. So it is a finite set. Very simple. Next, number 2, you can see they have written 1, 2, 3, dot, dot, dot. Now dot, dot, dot means what? It will go on. 3, 4, 5, 6 like that it will go on. So means it is infinite set. It will never end here. You cannot end up counting this. It will keep on moving like that. Okay, number 3. 1, 2, 3, dot, dot, 99. Then last element they have given 100. Means at 100 it ends up. So you can count and finish it, right? You can end up this one. So this will be your finite set. Okay. Number 4, the set of positive integer greater than 100. Greater than 100, what are the positive integer? 101, 102. Now it will go on, right? It will never end. So this is never ending set, that is infinite set. Okay. Next, number 5, the set of prime number less than 99. Less than prime number you can end up, right? Yes, so that will be your finite set. Okay, number 3. So what is the first question in question number 3? The set of lines which are parallel to x-axis. The set of lines. Now in the set, what are the elements? Elements are lines. What are these lines? These lines are parallel to x-axis. Now how many such line you can have? This is your x-axis. Okay, this is your x-axis. Now parallel to this, how many lines you can make? 1, 2, 3, 4, 5, 6, like this you can draw infinite number of lines or not. It will never end. So this will be infinite set. Number 3 will be your infinite set. Okay. Next, number 2. The set of letters in English alphabet. Obviously finite. English alphabet, how many? 26, right? So it will be finite set. Okay. The set of numbers which are multiple of 5. Set of numbers. What are these numbers? Multiple of 5. So multiple of 5, what are the numbers? 5, 10, 15, 20. Can you end up? Obviously no. So that this is infinite set. Okay. Next, number 4. The set of animals living on the earth. Now what is this? This is little debatable, right? Now set of animals living on earth. Now see, if you are good in doing research and all, if you can find out the statistic well, then obviously if you find out animals in this world, obviously there will be finite. Obviously it might take time, but there will be end for sure. Okay, so this will be your finite set. Okay, so as I said, if you can end up, does not matter how many days or how many years it will take to count up. If you end, means it will be finite. Okay, so animals, if you count at once all the animals in the world, then obviously it will be finite. I means why I said once, because animals will keep on giving birth, right? So in this way it will increase. Okay, so if you count today something and then tomorrow something, and in this way it will keep on increasing. Okay, so in that case you might think that it might be infinite. So at once if you count out, then obviously there will be end of counting those numbers of element. Okay, so it will be finite set. Okay, so I hope you are finding this exercise very simple, right? So that's why they don't ask question from here. Basically these are just to make your base strong for your upcoming chapters. Okay, and these things, if you want to understand, you will see how complicated the other topics used to be. Okay, and it's very interesting also if you understand. Question number 5, right? Okay, the set of circles passing through the origin 0 0. Now see what it will be. Set of circles means in your collection what will be the elements? Circles. Which circle? Those circle which will pass from the origin. Now pass from the origin, how many circle you can make? 1, 2, 3, 4, 5. So in this way infinite circle. From this side also you can make infinite circle you can make. So this will be infinite sets. Okay. Number 4. In the following state whether A is equal to B or not. So that you can easily find out, right? A and B are equal or not. Here what are the elements? A, B, C, D. 4 elements. Here also 4 elements. First count like that always. Okay. Number of elements obviously must be same. Then only you might have same element, right? So next you check whether same element or not. A, B, C, D here. Here what are the elements? A, B, C, D. Same element. So A and B are equal here. Number 2, 4, 8, 12, 16. Here 4 element, here also 4 element. Here elements are 4, 8, 12, 16. Here also 4, 8, 12 is not there. So obviously it cannot be your, what? Equal set. Okay, A and B cannot be equal. In this way you try to find out the other questions also. Okay, the video is getting lengthy now. Okay, and yeah, if I missed out anything in the questions, you just let me know. Okay, because I'm also downloading it from the internet only. Okay, I don't have book right now, so I may missed out something. So you please let me know if I missed out anything from the exercise.